In this example, we want to solve the initial value problem dy dx equal to y plus 3 times 9 minus y, and we're given the initial condition that y of 0 is 5. So anytime you run across a differential equation, take a step back first and determine if it's a separable differential equation or linear. In this case, we have a separable differential equation, so we'll begin by separating our variables. So we want to get everything with a y on the left-hand side of the equation, everything in terms of x onto the right-hand side of the equation. And if you had a constant by itself, you would always move the constant over to the right-hand side with the x's because it makes it easier in the long run to solve. So here in the denominator, we have y plus 3 times 9 minus y. In the numerator, we have dy, and bringing the dx over to the other side, we have is equal to dx. So now, from here, we can't integrate this as it is, so we need to use partial fractions to break up that denominator. So we have 1 over y plus 3 times 9 minus y. And so this is of the form linear and distinct in the denominator. Nothing is repeated. So make sure that you're familiar with the different forms of partial equations and that you use the one that's appropriate for the fraction that you have. Here we have a over y plus 3 plus b over 9 minus y. And then cross multiplying, we get 1 is equal to the y plus 3's cancel out in the first term, and so then it's a times 9 minus y plus b times y plus 3. To solve for a and b, I think it's easiest, if you can, to just use nice values of y. So for here, let's start with y equal to 9, because that will make the term with the a go to 0. At y equal to 9, we have 1 is equal to 0 plus b times 9 plus 3, which is 12. And solving for b, we get b as 1/12. The other nice value here would be y equal to -3. So at y equal to -3, the term with the b in it will go to 0, and we're left with 1 is equal to a times 9 minus the -3 is 12. And solving for a, we get that a is also 1/12. And so subbing that back into our separable differential equation, we have 1/12 over y plus 3 plus 1/12 over 9 minus y And the dy is still on the left-hand side of the equation. And that is equal to dx. Now, we can leave it as it is and integrate it, but it would be a lot easier if we didn't have to deal with those 1/12 on the left-hand side. Like I was saying earlier, if you can get a constant over to the right-hand side, then it will always be easier in the long run. So before I integrate, I'm going to multiply both sides of this equation through by 12. And now we're ready to integrate. So we have the integral of 1 over y plus 3 maybe I'll put those in big parentheses here, plus 1 over 9 minus y dy equal to the integral of 12 dx. So we know how to integrate this now. The integral of 1 over y plus 3 is the natural log of the absolute value of y plus 3. And then minus the natural log of 9 minus y. So don't forget your chain rule, that when you're integrating this 9 minus y, you do need to pull out a negative to the outside. And that is equal to 12x plus c. Using our natural log rules, we know that the natural log of a minus the natural log of b is the natural log of a over b. And so on the left-hand side, we can rewrite that as the natural log of the absolute value of y plus 3 over 9 minus y and that is equal to 12x plus c. And so now that we have a single natural log on the left-hand side, we can introduce e to both sides of this equation. And so e to the natural log are inverses, and so we're just left with the absolute value of y plus 3 divided by 9 minus y. Equal to e to the 12x plus c, which is e to the c times e to the 12x using our exponential rules. Now, to drop the absolute value signs, we can put a plus or minus on the other side of the equation. So we have y plus 3 over 9 minus y is equal to plus or minus e to the c times e to the 12x. And now let's let a have more room this way. Let's let a equal plus or minus e to the c. Okay, so now let's solve for the constant. I think it's a little bit easier to solve for your a value here rather than waiting till after you've solved all the way for y. So solving for our constant, we use our initial value that y of 0 is equal to 5. So subbing in 5 for the left-hand side of this equation, we would have 5 plus 3 divided by 9 minus 5 is equal to a e to the 0. And e to the 0 is 1, so we have a is equal to 8 over 4, which reduces down to 2. Okay, so subbing that into our differential equation, our solution, and then multiplying both sides through by 9 minus y, we have y plus 3 is equal to 2e to the 12x, and we cross multiplied here by the 9 minus y, and a goal to solve for y. So now we need to distribute on the right hand side of this equation. So we have y plus 3 is equal to 18 e to the 12x minus 2 e to the 12x y. And now we want to get all the terms with a y on the left-hand side and all the terms without a y on the right-hand side. We will add the 2e to the 12xy to both sides. And we'll subtract 3 from both sides. So I'm going to make a little more room here to writing a little bit large. Okay, so on the left-hand side now we can factor out a y. Then we are left with 1 plus 2e to the 12x equal to 18 e to the 12x minus 3, and dividing both sides so that we can solve for y, we get that y is equal to 18 e to the 12x minus 3 divided by 1 plus 2 e to the 12x. And that is your final answer.